Cool. So, hi, everyone. I'm Brandon. Thanks for the introduction. So, I am an engineer on the core platform team at Pinterest. I come from San Francisco. It was a long trip. Today, we're going to talk about why strings are evil, but we're really just using this as a motivation for phantom types. So, keep that in mind. So, shall we begin? OK. Strings are evil because they're sneaky and they're omnipotent. OK? And my slide notes are busted. Let me just.
Maybe you could say with the flux.
Oh, yeah, thank you. I was wondering what. How's that? Sorry. OK. Cool. So strings are sneaky and they're omnipotent. All right? Why? OK? They're sneaky because when you see a string, or when the compiler sees a string, most of the time you don't really mean just a string of characters, right? There's some underlying context associated with that. So for example, like you might have a database column name, you might have a username or a user's password, and these are all distinct entities in our minds that behave differently, right? And they're omnipotent because these distinct things, they shouldn't be just interacted in the same way that all strings are interacted with, right? Like it doesn't make sense to concatenate database column names, for example, right? I mean, most of the time, right? And it doesn't make sense to, if you have like an MD5 hash, to split it, because then it's no longer an MD5 hash. So these are some bad things, right? And we want to make the evil strings not evil. So let's start making that a little bit better. OK, so first of all, I have a function here, simple function. Join paths takes two parameters, p1, p2, two strings, returns a string. OK? What does this do, right? If you look at that, you're like, OK, we're joining paths. We're in the context of like programs. What's some useful paths? Like probably file paths, right? But then if you go and look at an implementation, what if we're talking about SVG paths, right? So this kind of this property of like not understanding what something is without looking at the implementation is pretty bad, right? And it's bad not just for humans but for the compiler as well, right? So we're going to just talk about joining file paths for the rest of this talk because it's a nice simple example with strings. But I want you to keep in mind, like all these things we're going to go over, you can apply to any string-based API, and really other APIs as well. So keep that in mind. OK, so at this point, how safe are we, right? So we have our join paths, takes two strings, returns a string. The problem, that I already mentioned, humans and compilers don't understand the context of the string, the fact that it's a file path, right? But we have some other problems. We can make invalid file paths. So if your file system doesn't support poop emojis in file names, or if we have slashes in our file names and we don't escape them properly, we'll construct something that doesn't make sense, right? And additionally, we could join two paths that don't make sense. So even if those paths are correct themselves, if we have a file on the left and a directory on the right, when we join them, we get nonsense. OK? So sorry, my left. So let's start breaking this down. We need to unveil the sneaky string. OK? And we can do that by giving the string a type. So we can wrap our string in a struct, and we'll just have an initializer to make it easy to use. And then our join path function signature is a little bit easier to understand, right? We take two file paths and we return a file path. So now we know we're not dealing with SVGs, right? And this is good. And this like thin struct wrapper, it shouldn't affect the underlying like bit representation of the data, right? Like that's what you'd think. And I've heard a rumor that in a former version of Swift that was true. It's not true right now, but you can imagine this should be true in the future, right? It's really just a string under the hood. And for those that are like really familiar with Swift, but not familiar with this technique, you might be thinking in your head, hey, I can already do that with type alias, and it's a lot less code, But but this just changes the name, okay? So this is also kind of equivalent of just changing the parameter names of your function, you know? And this is okay, right? It provides more context to humans, but it doesn't provide any context to the compiler. So if you have a username and you store it in some variable x, and then that's like flowing through your system, you have a bunch of functions everywhere, a bunch of branches, and eventually you're gonna invoke join paths. If you accidentally provide a username here, your code compiles and you end up with a garbage piece of information. So that's bad, and we want to make bad things hard because we want to do the right thing most of the time, right? So using the struct wrapper, we get a fresh type. File path is no longer a string, and because of that, let's say we do that everywhere, right? If you invoke join paths with the username, now you get a compiler error that says, you know, cannot convert value of type username to expected argument of type file path, right? So this is great. And the distinction here between the struct wrapper and the type alias is this notion of nominal typing versus structural typing. So confusingly, the nominal type is the struct wrapper, and right? But it's called a nominal type because the compiler treats it as a different type just because it has a different name, right? Like under the hood, it should be, in a perfect world, like the same bit representation as just a plain string. But because the name is different, we're going to treat it different. And you can do that by using the struct, right? The structural type is more of this idea of saying, like, if I have something that's the shape of a string, then I'll treat it like a string. And that's why file path is treated in the same way as a string. So personally, right, type aliases are good for, personally, this is what I think, right? Type aliases are good for shortening large generic specializations, right? So you don't have to have like a crazy long type everywhere in your code base. They're bad for doing things like this. And a lot of people use type aliases for things like this, but that only provides context to humans, and we want to also provide some context to the compiler, right? So that's not all we get. Also, if we're using the struct wrapper, we get some nice things because of Swift, which is cool. We get a method namespace, so we don't have to have this free function, right? And you know, we don't want to put an extension on string. That's evil, right? So now we have our own namespace for methods. So that's pretty cool, and we can implement the file path join here. And you can see, you know, we have to wrap our strings back up in our struct wrapper, which gets kind of annoying. But with string literals, if we conform to expressible by string literal, right, we can make our file paths just ad hoc, right? Or the compiler makes them for us, the constructor application there. So that's pretty nice, right? So at this point, we're a little bit safer, right? And maybe a lot of you here already knew about this technique, but we're going to get deeper. All right. So we still have two more problems, right? We can construct invalid paths, and we can join paths in the wrong way, in ways that don't make sense. So let's think of the first problem, right? We have improper file paths, and we want to prevent them from existing, right? So we need to add more structure to our type. And normally, when you think about this, you know, this is kind of like where you reach for algebraic data types, right? So normally, you know, we're gonna dig in and we're gonna use an enum, okay? So first, we're making our struct wrappers. We're making a file name and a directory name, different, distinct types. They're both different from string. Then we're gonna make our enum, and it's gonna be recursive. I have that indirect there, right? So if you think of a file path, right, like what is it in its essence, you know? It's either the root path, right, just a slash. It's a current directory. That's the dot, usually. It's some path up to some directory, right, where like the file path is recursive. And it's some path up to a file name. And then you might also want like something for the dot, but I'm going to omit that to keep it simpler. So this is pretty interesting, right? If you squint, this kind of looks like a linked list, which I found pretty cool, right? Because we have two base cases though, and we have two recursive cases. But the recursive cases only add one extra piece of information. So you can kind of imagine, like, you know, if you think of a file path, it's really just like a list of directories, and maybe it ends with a file. So you know, the linked list thing kind of makes sense. But if we just do this, we don't get any safety, right? Like, we can still stick a poop emoji in the directory name. right? Nothing is stopping us from that. So what we want to do is we want to make these enum constructors private, in quotes. So and until today, I couldn't come up with a nice way of doing this, but Chris and Florian helped me figure this out. So we can make our enum private. I'm going to just prefix everything with underscores because that's like a thing, I guess, you know. Just to keep it simple, right? So that we know the difference between public and private. And then we want this file path to be exposed publicly, right? So there's not a super easy way to do this, but we can have a struct that wraps our enum, and then the enum has a file private field. The constructor, right? So this will work as long as we invoke the constructor in our framework, right? In our own package visibility situation, right? Sorry, I'm jet lagged. So we have our private constructors, right? But we need a way to make file paths. So we want public constructors. So we can have the root, right? There's only one of them, so let's just make it a let. And that's just the root, right? The current directory is just the current constructor. But now when we have a file, we have a function that takes a file name, and instead of just blindly creating our enum case, we're going to escape the name, and that'll protect us from having poop emojis or slashes in the name of the file or directory. And then we do the same thing for a directory. So now we have this way of building these chunks for paths, but we can't build like paths that have multiple directories in them, because if we had a slash in any part of our string, it just gets escaped and it becomes part of the name of that folder or file. So we need to use join, actually. We need to use join even when we're making larger paths. So we have our join, right? It's the same signature as before, the method version. But now we have enums, so we need a switch, right? So let's look through the cases. OK, I'm joining two current directories. That's the same as just being at the current directory, right? If I have a root and then a current directory, it's just the root. If I have a path to a file and then the current directory, let's just like stick the dot in the path up to the file name. We can do the same thing for directory. And then if I have any sort of path and then a path to a file, I can take those two paths and just join them together and then stick the file at the end. And same thing for directory. So there's a few other cases here, and I'll get to those later. But for now, this is like the core part of this logic that you need. So this join operation is a semigroup, algebra. Here we go. So I'm not going to talk about semigroups today. So for those that don't know, doesn't matter. The important thing is that this join operation is associative. This means if I think about joining a lot of different chunks of a path together, it doesn't matter how I parenthesize those joins, right? And it works. We can call join on any file path, and it takes two arguments, whatever. So we have a semigroup, OK? And the nice thing about having this semigroup is that we get to implement this diamond operator. And normally, when you have an associative operation, it's nice to use an operator because you don't have to parenthesize. It kind of makes it easier to use. So this is just a nice thing. We can invoke join. It's fine. So now we can build up our paths, right? We can build up our paths. We can join paths together. But now we have this enum, and maybe we want to interact with some other APIs, or we want to display the path to the user. So we need some way to go back to a string. And we can just stick a render function on our file path. And we can take a path separator, right? And this will catch the case where we want to support Windows-style path rendering in our iOS apps, obviously. But that's a little nice bonus. And then we can recursively go through all the cases and just say like, oh, when I see this, I'll render this part of the path. And I'm not going to show that. But now we have this nice DSL. So we can make little chunks of our file and join them together. Here I'm making sources, models, foo.swift. And then when we render it, we get out the path, which is nice. OK? So this is pretty cool. Some of you are up to now, you're probably like, hey, I already know this stuff, whatever. Maybe it's new to some of you, and that's great. But, and we're a little bit safer, right? But there's still this one thing that's missing, and I've been bitten by this before. But we're allowed to join invalid paths together, okay? And the way that we fix this is really interesting. That's the whole reason I made this talk. So, okay, so this is an example, right? This is wrong for two reasons, okay? This particular join. So the first reason is we have a file on the left, like I already talked about. That doesn't ever make sense, right? We can only join paths when we have directories on the left, your left. And then on the right, we have an absolute path. So root is an absolute path, right? So it never makes sense to join the root or to join any absolute path on the right. Okay, so we have this interesting asymmetry here. So here's a slide with those two things, right? We don't want to ever join with an absolute path on the right, and we don't want to join with a file on the left. Okay, so there's a couple ways you can fix this, and a lot of them are bad. So let's go through the bad ones. So one thing, I didn't show you the extra cases, right? So here's the extra cases, the catch-all. And actually, you need to put a few more pattern match cases in here to get this logic right. But we could just crash. And a lot of people are OK with this. But at a functional programming conference, you should not be OK with this, right? So we don't want our apps to crash. This is just bad. So if we don't want to fail at runtime, then we have to sort of encode this, these invariants in the type system somehow. So the first thing you might think of is, we have absolute or relative, and we have file or directory. So let's just make all those combinations. And we'll just make a bunch of enums. And then join is now, we have 16 overloads. Well, actually, we have like 14 or something, right? Because we omit certain cases. But then, all of our other file operations, we have to implement over and over and over and over. So this is bad. You get this like combinatoric explosion of cases that you have to deal with. So phantom types. This is what we want. So, okay, what is a phantom type? Here's a very, very, very simple example. Okay, so let's look at the code first. So I have a struct phantom int that's generic on a type parameter a, and I have inside the struct a single property I of type int. Nowhere am I using a in the definition of the struct. Okay, so this is a phantom type. So if you don't use one or more of your generic type parameters in the body of your struct, then you have a phantom type. And if you're staring at this and you're new to phantom types, you might be like, hey, this seems super not useful. Like, what's the point? What's the point? Well, let me rename this type. I'm going to rename phantom int to distance. Okay, and now we can use this phantom type parameter to tag our type with extra metadata. So we can tag distance with meters, and we can get the distance in meters. We can tag it with inches. We get the distance in inches. Then we can write operations that make sure that we're only combining things that make sense, or we can provide overloads that do the transformations for us. And this is similar to the unit API in Foundation. But the interesting thing about this implementation is that there's no runtime value for this unit, right? This only exists at compile time because there's nothing that's storing a property of type A. Okay, so this is pretty interesting, right? All right, we need a phantom path. Okay, I'm going to drop the file from path here because I just want it to fit on a slide. But we have the same indirect enum, right? But now we have two generic type parameters. We have one k that conforms to a protocol path kind, and one t that conforms to a protocol file type. And I haven't shown you the implementation of path kind or file type, right? But I will soon. And then we have all of our cases, and it's exactly the same, except the recursive step just has to forward along the generic parameters, right? But again, we're not really using k or t, okay? And I'm going to skip the public wrapper hack that you have to do just to keep the rest of the slide simple. But this is basically it, right? Then we're going to take our our constraints, our type parameters, and we're going to make something like this. So we want to make an API that's going to end up to allow us to say, like, I have my root joined with users, bcase, hello.swift. And then if I look at the type of that, I get an absolute path to a file, right? So the compiler understands the exact semantics of this particular path, right? So let's look at path kind and file type. So we have an empty protocol. So path kind is just kind of a namespace for the things that we're going to put in our generic, our first generic parameter, right? So there's two possibilities, absolute and relative, okay? And we're going to make these empty enums because we don't want anyone to accidentally create one of these at runtime. These things only exist at compile time. It's just metadata for the compiler and for humans to more understand the code, right? And then we do the same thing for file type. You have a directory or a file, and that's it. Okay? So now we can go back to our public constructors, right? And we can explicitly specify the generic type parameters. Okay? So when we have a root, we have a path, an absolute path to a directory, right? For the current directory, we have a relative path to a directory. Okay? For file, we have a relative path to a file, and for the directory constructor, we have a relative path to a directory. Okay? If you're a table, Excel spreadsheet person, here's that information in a table from Excel spreadsheets. So here's everything I just talked about. Okay? So now here is the most interesting part of the talk, this slide. Okay, so we are no longer going to define the join method on all paths. Okay? We're only going to define it on paths that are directories. So we can just have an extension only when T is directory. And then the path that we're passing in is only relative, right? Because this encodes that constraint, right? Like we can't call join when we have a file, and we don't want to pass in something that's absolute, right? Then the return type takes the kind from the first part of the path, right? So it's if we were absolute, then we're going to be absolute after our join finishes, and it takes the type from the second part. So if we were a file, or if we were joining with a file, right, the result is going to be a file. If we were joining with a directory, the result will be a directory, right? So our switch over our two enums is literally the same exact code as before. Like nothing has changed, okay? Literally. But we get this nice property where this extra crap that threw a runtime exception is now unreachable, right? We can't prove to Swift that it's unreachable, but it is, right? And because this assumes that we behave within our library and never manually create one of these underscore constructors. We only use those public constructors, right? But that's cool, right? So we're going to make a new operator because we have a semi-groupoid now, not a semi-group. I'm not even going to talk about that, but it doesn't matter. It's a new operator. And then we just take our two paths, we invoke join on them, and then we can make paths like this, right? But this isn't the good part, right? Like, yeah, we've always been able to make paths that were correct. The good part is that incorrect paths cannot be created. Okay, so if you try and join a file with a directory, you get a compile error, and if you try and join a directory with an absolute path on the right, then you get a compile error, right? So our invariants are captured in the type system. And you can use these parameters, these generic type parameters, to do other interesting things. Like if you have some relative path, we can canonicalize it and fix up all the dots and like look at your current path, and get an absolute path out, right? So we can do interesting things here. And at this point, we're safe, right? So we won't accidentally pass a username when we mean to pass a chunk of a file. We can't construct files with poop emojis. And we can't join files with directories or anything, right, if the file's on the left. And we can't join with absolute path on the right. So you could say that we've vanquished the evil string in our file paths. And that's pretty cool. And I just want to show a couple more examples of phantom types because they're like really amazing. So one thing, right? You can use this type parameter as to represent the current state of some sort of state machine. So here we just have like a very simple machine that, let's say it's like going to accept the coin and give you a candy bar or something. But so you can take this as a parameter or make it a method or whatever, but you can take a machine that is in the state of no coin, and when you put in a coin, you get back a machine that is in the state with coin. It's the same type, but now the compiler will make sure that you don't put in 2 coins without first getting your snacks out, right? And Brandon and Steven are using this for the Swift web stuff that they're doing, which is really cool. So you can check that out. And then we can also make this tagged struct, right? So we're generic on 2 parameters, A and B. B we're going to actually use, okay? But A we're not. And so we can use A to store our like compile time metadata. This is like our phantom type parameter. And we can wrap any type in the universe and annotate it to add like extra semantic information. So that's really cool. I want to give a shout out to this library, PureScript Pathy. They invented this representation of file paths. And when I saw this, I was like, oh my God, I got to get this to work in Swift. And then it worked. So, so what do we talk about? OK, raw strings are sneaky because you don't understand the context, and the compiler doesn't understand the context, right? And they're too powerful because certain operations we don't want to allow, right? Names or type aliases, which is structural typing, is not sufficient for fixing this problem because it only provides context to humans, doesn't provide context to the compilers, right? The struct wrapper, which is nominal typing, gives that extra bit of context or shares that context with the compiler as well as the humans. And then we can use enums and algebraic data types to prevent invalid states at construction, but they don't prevent invalid combinations of those values. That's something that you need something like phantom types to do properly. And that was like crazy, when I realized that. So, so strings are evil, right? We couldn't do any of this stuff with strings. And when you're just using strings blindly, you kind of just are like, hey, I don't care about having bugs. So we should care about that, or something, Do I have question time, or? Yeah, this is a question. Cool. I'm going to drink water.
I'm also slightly vague out a bit when you're talking about preventing invalid characters in the path. Could you quickly just...
Yes. The way we do that, excuse me, is by escaping the name when we construct the enums. Sorry, I choked on water. Right, so does that make sense? We're making the actual enum cases private, and we're only allowing you to create these parts of our file path through these public static functions, and so we can ensure that we escape anything that's invalid.
Does the PureScript library have the ability to prove to the compiler that the unreachable paths are unreachable, or how do they handle that?
It's the same thing,
okay.
Unfortunately.
Did you already mention whether you're going to, or if you have plans to release this? Or?
Yeah, I can. Sure. Yeah. No, I have like a playground, but I haven't turned it into like a GitHub project. But it sounds like more than 0 people are interested. So sure, I'll do that. Just look at my GitHub or Twitter, and I'll tweet/share it.
Can you prevent someone from making new of these types, like absolute relative? Like you can't stop someone from making like a foo.
Yeah, that's a good point. I haven't even thought about that until now. But I think you can do the same sort of thing. Okay, a Swift expert may correct me. Feel free to correct me. Can we make the protocol private, but the type public? No, probably. Okay, so I don't know. That's an open problem, whoever asked that. Yes, I don't, that's a good point.
Would it work with your API?
Yeah, it's no problem for your API.
Yeah.
That's true.
Look at the type of the join.
Yeah,
Yeah.
it'll work. Cool. I mean, it's kind of, let's look at this. Yeah, it'll work. That's actually a feature. Cool. There's this hand over here.
So, what is your experience in terms of Swiss compiler errors and Swiss compiler crashes and writing this?
Yeah.
You can't really defend it on type system.
I had 0 compiler crashes when I was messing with this stuff, which is, I know, crazy. So the generics are pretty good. I mean, if you don't nest them in weird ways, but the constraint logic, I haven't had trouble with recently. So.
I very much like using session types for modeling state machines like you did with those phantom types. But in Swift, the remaining loophole that I often see as a problem is the lack of affine types. So you cannot prevent the branch of a state machine. Do you have any experience with like how to get this somewhat more safe?
My experience is I've read about affine types. I have not attempted to Swift them. So I don't know. But that could be interesting to try and hack in.
I think you could make the same argument about the evilness and the omnipotence of for every type in the standard library. I'm wondering, like, what's your personal? Have you encountered situations where you say, "This is really adding more overhead than it helps me," or like, how do you make this?
Totally. That's a great question. What? Yeah, I think strings in particular are one of the most evilest types. So if you think of the number, if you just think by like, what is the number of ways I can inhabit a string? So like, what are all the possible strings that exist? And there are a lot of them. And I really, most of the time, you only want to allow a finite subset of them. And so that's why, doing things like trying to fit a representation into an enum, it makes it so that the subset that you care about is what's allowed. So I don't know. So okay, the question: what other standard library types? I think like collections are fine, in general. But I think the primitives, using an integer constant instead of an enum, for example, is one of these like things that is nice because you're kind of constraining your situation. That was not a like super put together answer, but hopefully it gets my brain across. Yeah?
Could we use the compiler to prevent us from showing untranslated, unlocalized strings to the user by saying that all our UI views, all our UI, like everything UI doesn't accept normal strings anymore. You can't set a normal string, you have to set a localized string.
Yes. That's a great idea. You should build that library. Yes, that's a great use case.
That's a last question.
Oh, okay. Talk to me later in a break or something. Here's